So next up will be all of these. Interestingly, these are saying 201. It's 20 and 10, so 200 ohms. So this is a different value than what the parts list gives. The parts list gives 330 ohms to 1K. That's interesting. I didn't look at those on the one that I built up earlier. So simply, these are for every other resistor on the board. This is the last resistor value. So what we can go through and do is tin one pad on every resistor position that's already on the board. Now we already did one by mistake, but we shall go through and do the rest. And then we just go through doing the same thing again. Let's try bringing you in a bit closer so you can see. Ooh, not that close. Sometimes you can feel that the component is a little bit up in the air, so you can just press on it with your tweezers and then reflow the solder. That just helps to sort it out. So now that that is done, we can now go around making the other half of all of these joints on the components. So now we move on to some of the semiconductors, and we'll start off with the diodes. These are just simple signal diodes. I think they're 1N, what are they? Oh yeah, 4148, little signal diodes. These are round components. So these are for positions D12, 13, 14 and 15, as you can see here on the diagram. And if we turn our board around to match, we've got here D12, 13, 14, 15. So let's tin just one pad of each of those. Helps if you have your soldering iron turned on. When filming, it often takes longer, so I often turn the soldering iron off in between bits. And I shall turn the board because it's easier for me. Now, as you can see on the board, there is the traditional diode symbol of the arrow pointing into the little straight line. And on these components, you can see that they have a black stripe, just as normal diodes would either have a stripe, either black or white, depending on the package. So do these. And so the stripe goes to the stripe on the board. And it's good to do these in groups, so that instead of trying to solder both ends of the same component, one immediately after the other, actually by having 4 or a number, you're able to allow the component to cool down a little bit. It doesn't matter so much for simple resistors and capacitors, but for semiconductors it can mean the difference between it working or it being dead. Now we can come back and just add a little bit of solder, basically adding the flux more than the solder, which just makes sure that the joint is not dry but is good and is sound. So now we move on to something a little bit more adventurous. We're going to put in these little transistors. So these are the transistors. As you can see, they have two leads on one side and one on the other. As you can see on the board, we've got two on one side and the third package there. If I just tilt this up to get rid of the glare, you can see the little square symbol. So it is possible to put these on in the wrong orientation if you really try, but as you can see it matches up, even that's skew with, but it does match up. So we do the same again. We will tin up one pad for each location. So these are a little bit more finicky to put in and get in place, because they've got the extra lead, and also you're mindful of not overheating them. And they really like to move about. Now you may have noticed that on these transistors, the pad spacing on the board is pretty much exactly the same as the transistor package, whereas we find with these resistors and even with the diodes that there was quite a bit more pad around where they should go, which makes it easier. These you can make it hard for yourself if you don't position the actual transistor correctly on it. You can obscure some of the pads, which makes it a bit tricky to solder up. As you can see, I'm going around doing just one leg in turn of each of these, just so that I'm not bringing too much heat into the component, if I can help it. Sometimes you can't help it. Just wanted to see with this Q2, because I have actually obscured some of the pad with the positioning of this. I just wanted to make sure that those joints had actually made. So now we come to the LEDs. I'm going to move the circuit board out of the way for a minute. These LEDs, there's 15 of them in the kit, or in this kit anyway. Now, as you can see on these, there's a green stripe. That is significant. Let me just get my multimeter, the diode mode. So we can see that going that way does no good, but when we do this way, it lights up. So the stripe is the negative or the cathode. As you can see on the circuit diagram, there's a stripe, or not the circuit diagram, the PCB layout. And then if we bring the PCB in, you can see on all of these, like D10 here, we have a thicker border on one side. That's the stripe. So that's the side that green stripe goes towards. So we'll do the same as we've been doing before for our LEDs. We'll just tin one pad, and what I do is I tin that pad that has the stripe. And we can see that the stripe is LEDs are a little bit more sensitive to heat than ordinary diodes, in my experience anyway, so you just have to be a little bit swifter. So before I do any more soldering on these, what I like to do is again bring my meter leads in with the diode test function on, and because we're able to go around, these are all common, the ground is all common on them, so we can just see, oh, this one didn't solder too well. We can just see that those solder connections did go alright, apart from that one. Just tilt that up and then you can see that those are all got the stripe on the same side next to the stripe on the circuit board. So now we can go around and solder the other sides in. Now we can move on to adding the integrated circuits. Same principle again, we tin one pad. Now if I tilt this up to get rid of the glare, you can see that we've got the silk screen showing that this is the top of the package, and obviously that is pin 1. And again with the 555, we've got the silk screen showing the top of the package is up at this end, obviously pin 1's over there. Just because my soldering iron is on my right hand, I just tin this top right hand pin. So now we just are quite careful with this, and we just reflow that. And I'm just applying pressure down on this so that it's sat down properly on the board. That's the way you want it. You see the legs are pretty much central in the pads, very nearly. If you have it overhanging, then you're in trouble. And of course we have the little dot indicating pin 1, which is up against the pin 1 of on the circuit board. Again, we've got a dot on this little integrated circuit. We know from the silk screen that goes up to this end. Okay. There we go. So we just need to make a... Oh, that's what I'm saying, these are so easy to misalign. Sometimes what you can do is you need to do a couple of pins on these larger ones just to make sure that the alignment stays. A bit of flux always helps. In fact, I would go so far as to say that doing surface mount soldering for integrated circuits like these, it's essential to have flux. What it allows you to do actually is to carry the solder over to the joint and make it. It also means that if you do get a bridge, it's really easy just to drag that away. As you can see, I don't have much solder on my soldering iron, and it doesn't need much. You can see there I've got a bridge. I got too much solder on, so I'll just clean my tip, put a bit more flux on. It's not a problem, you just stroke that away. Can't quite do the normal thing with soldering integrated circuits and soldering one pin at a time. It's usually several go at a time when you're doing surface mount work. And don't be shy about using plenty of flux. The only thing we've got left to do is to put a couple of blobs of solder on our power input, and I think we're pretty much ready to test this. I just wedge this up, keeps the glare off it. So I'll just move that to one side. I'll bring in the one I made earlier, and I'll remove the USB lead, power lead. It's just a little normal USB to snip the end off. And then we've got this. So we've got our positive on here. It says 3 to 12 volts. I'm not sure. I would like to put it on 12 volts. But now, the moment of truth. Let's see if it all lights up. Hooray! It does. So what's happening with the circuit here? This little chip, the 555, is running as like an oscillator, pulsing output. And this LED here, that's showing the output of the 555. That output also, as well as driving this LED, drives the input of this counter circuit. This then provides 10 outputs for these 10 LEDs going round. So you can see it's counting round. Every time this pulses, it moves on round. When it gets all the way through to 10, it puts the output, the overclock on, which these 4 LEDs are driven from. So you could, if you wanted, if you had several of these 4017 integrated circuits, you can cascade one after the other. And so one will count up the tens, the next one will count up the hundreds, and then the thousands, and so on and so forth. But the good thing about this practice SMD soldering kit is, unlike some that just give you a bunch of components that you solder on, but you don't know if that is working or not. This actually, you can hook up some power to it, just a battery bank or a couple of AA batteries even will drive it, and you will see if all of your joints are working. If you haven't soldered some joints correctly, then certain parts of it will not light, and so it can be a good exercise in troubleshooting as well. But we hope you've enjoyed this video. I hope it's been of some help. We thank you for watching, and we'll see you on the next one.